Hello, everyone.
Hey, guys.
Welcome to Rational Science, the only site on the internet that does science, does physics right. You might say, hold it, you're the only one who does science. Yeah, and that's because we redefined science sometime back, 20 years ago, okay? And you don't have to agree, but the way we do it in science, we don't lift our hands and vote. Okay, well, the way we do it in science is we define. We have to define what science is, and we have to defend that definition when someone attacks it and proposes a better mousetrap, right? And so we define science not as mathematics, not as description, not as prediction, okay, not as observation, not as measurement. We define science as explanation. You have to have an explanation to have a theory, and science is a body of theories. Whether you believe in the theories is irrelevant. We don't believe in science. In science, we explain them so that you understand them, and they better be rational, and there are criteria for that as well. Okay, and so today, as usual, we're going to divide our lecture in three parts. First part's going to deal with extinction, the extinction of man primarily. And the second part's going to deal with the review of what we did last time. Oh, I hope everybody's listening. I just received a message from YouTube saying not enough video. That is weird.
Did you send me I got the URL? Because I can check it. You sent this to my email?
Yeah, you got it.
I'm gonna go check.
See if it's right. Give us a second here, guys. I think it's okay because in Iceland I had the same problem, but it was choppy. Here I don't see it choppy yet. So give us a second. Let's make sure we're okay. Give me a message if you think that you're not receiving a good stream. Okay. Let's wait a second here. Says YouTube is not receiving enough video to maintain smooth streaming. So I don't know what's going on. I hope everybody can hear me right. I hope everybody can see me right. Let me know otherwise. You sound good to me? Okay. I don't know what's going on. I received a message from YouTube saying they're not receiving. Yeah? Then I don't know what that error is all about. Okay, let me continue then. Thank you, guys. I don't know why that message came up.
False alarm.
False alarm? Jesus Christ. Scared the hell out of me then again. Okay, anyways, we're going to divide it in three parts. And the first part, we're going to do extinction, especially the extinction of man. And past extinctions as well, you know, mass extinctions.
You make it sound like we already died. And other extinctions that happened.
And I'm going to move into a review of what we did last month, which wasn't too great because I was in Iceland, and again I had all this streaming problem, but there it was really bad. And then I'm going to move into the questions people asked, and then people can ask questions today based on that material or anything you want to ask. So let's move on to what extinction. Okay, let's start there. Just briefly, what is it about for those of you who are new, who haven't been around here, around this channel? We're saying that we are the last generation of humans on Earth. And no, that is not a joke. We're serious about it. We're saying we are the last generation of humans on Earth. Is it because an asteroid's coming towards us? Are we going to die because of some disease or
Global warming?
Global warming or something? No. We say that all mass extinctions, all of them, including ours, the upcoming extinction of man, happen in the same way. And ours will happen in that same way as well. And that is the collapse of the global economy. Once the economy collapses, no one produces food, and no one trades food because food will be the only thing of value.
So you're saying the economy of the dinosaurs went out? Their dino dollars?
We'll get to that in a second. Someone had a question along those lines. We'll get to that in a second.
When the jokes become reality, okay.
But yeah, so we're saying that there's going to be a global economic collapse. And when, not if, but when that happens, it's the end of man. And I think it's going to happen relatively soon. I don't have a crystal ball. I can't give you a date. I don't know when it's going to happen. Here we only talk about the mechanism. We're interested in the theory. Whether you believe in the theory or not, well, that's your prerogative. Okay. Okay. So I started with some homework with some homework the other day, and the homework was like this. It said, and I cover your face. I hope you don't get offended by that. Why did the fauna in the seas disappear at the same time as the animals on land?
Which
Okay,
extinction are we talking about?
it doesn't matter what extinction, whether you take the
But to clarify, in every extinction there were land and sea
and air.
and air. Well, yeah.
Air, land, and sea, just like the Marines and the Army. Yeah. So we had air, land, and sea, and all these animals, more or less, all these species, all these orders, because we're talking about really the big five mass extinctions. All these orders disappeared almost completely. Some in some instances, a couple crossed the line and they died shortly afterwards. Anyways, but in general terms, when the mass extinction happened, the animals on land, in the air, and in the seas died more or less at the same time. Maybe there were a few thousand years difference, okay? But the issue here is that from a geological point of view, you can say that they died at the same time. You cannot tell the difference in the layer of rock, if there was 1,000 or 2,000 years.
It's like a drop of water in it.
Right. They count all that in millions of years almost,
Yeah.
okay? So maybe there was a difference between the animal in the land and the one in the seas, no problem. But they more or less, basically in general terms, they died more or less at the same time.
And also to clarify, it wasn't all animals on land, it was specific ones.
Aside
Not
from
all the ones in the ocean.
that,
But
you need to explain
ones.
selectivity.
Yeah, why did some die and not others?
But the issue is, if you can figure out why they died more or less at the same time, you have discovered an important clue to the cause or the mechanism of mass extinction. Okay? So that's the point of the homework. Well, one guy gave it a try, and he came up with this.
Oh, many people tried to answer this, or what?
Well, no, just one guy so far. I like this answer. He says, the force we experience, known as gravity, killed the dinos. By increasing weight upon their limbs to ridiculous quantities, they were crushed by variable laws not so constants of physics. Okay, no problem. So you told me how the big dinos died. Okay, they were so big, the gravity crushed them.
That's kind of a good
Okay,
try.
Let's go.
Like that one.
Let's go with that.
Because real quick, that would explain why the big ones died and the small don't.
Okay, let's go with that one. But now that's a brachiosaur. People know as brontosaur from Fred Flintstone
Or Jurassic Park.
or whatever. But then you have that other fellow there. He was in the water. He was a reptile, and his name was the mosasaur. Okay, he was a reptile that was in the water, disappeared around the same time again, maybe 1,000 years difference, whatever. And did gravity kill him as well in the water? Okay. And it turns out that, he ate ammonites. And ammonites also disappeared around the same time. And ammonites ate the plankton, foraminifera and diatoms. And those disappeared as well. And those were tiny little things. Did gravity make those disappear as well?
So it's not big.
No,
it's not just size that they killed them.
But nice try, anyways.
Yeah.
Okay. No problem in considering all the possibilities, but then, one of the things you got to do is be a critic of your own theory, and it's very hard to do that because people have these strong feelings about their theories, about their beliefs, and their whatever, the way they were brought up.
I don't think it's hard to do if you're actually trying to get to the bottom of it. It's hard to do if you just want to be right.
Yeah, but it's one of those things that when you grew up with something, for example, for many years, like Christianity, or in my case, atheism, it's very hard to get rid of that. It really is, So it's one of those things where you sometimes learn the hard way, like I learned the hard way. But it'd be nice if you criticize your theory before you get to a point where you really break down and say, "Oh my God, I believed in all this nonsense for so many years."
Well, that's the good thing. If you don't criticize it, someone else will. You'll find out eventually.
Exactly. Okay, next issue. Fellow says. He says the ice age killed the animals. And there you see all these animals poor. They're in the snow and in the ice and the glaciers. I just came from Iceland, and boy, it's full of glaciers. And
They still have the ice age up there.
Hasn't stopped yet over there.
Is that a Dalmatian dino?
Which one? The one in the bottom or in the middle?
Yeah, this one.
No, that's like a T-Rex.
Yeah, but it's white and black with black spots.
Yeah, they paint them any color they want, you know. But the issue is, did they die? Did these dinosaurs die because of climate change? I mean, we have climate change so much in the news lately, and people talk a lot about it. The politicians, you know, they have all these international meetings. They talk about climate change. There's this Norwegian girl. What's her name? I remember. And she talks about climate change. So everybody's into this climate change issue. Because, you know, they go to the North Pole and they see, you know, the glaciers melting and the poor little bear is sinking in, you know, polar bear is sinking into the water. So, you know, people talk a lot about climate change. Did climate change ever kill a single species on planet Earth in the history of life on Earth?
I would say, yeah.
I'm saying never did.
I would disagree. I'm sure one.
Okay, and now go to...
I'm sure. Well, I don't know. I'm sure one or the other would just got too hot for them, but then they would have just evolved with it.
Or go to somewhere else.
Oh yeah, go somewhere. And maybe not. Maybe
you know, it's one of those things that when the going gets rough or when the going gets hot, the rough get moving. You know. So,
I'm sure the species all just adapted to whatever the temperature was.
Temperature goes a little slower, maybe than evolution, or maybe just about, but certainly moving to a better climate is a faster way to elude, you know, the incoming cold, for example. I don't think there was an issue of hot, but there is an issue of cold, at least for past extinctions. At least that's what people analyze. Okay, go with the next question or comment. Where is it? Here. One guy says, the dinosaurs are gone because they ran out of money. Hey, that's my theory. Don't steal it from me.
Hold on, I'm gonna go check the stream again.
What? Something wrong?
Keep going. Oh, you just got buffering. Let me check if I get it.
Getting buffering stops. Okay, so there is a problem. Aha. Now I show that it shows an excellent connection. Maybe it was temporary. Okay, maybe it was temporary. Keep giving me messages. We'll find out if it's any good. My son went there to check to see if our connection is good, but right now I show it's good from YouTube. YouTube is saying that I get a good connection. Okay, maybe it was a glitch for a moment.
Yeah, sometimes it has buffering.
Okay, I think it's all right now. We'll play it by ear, okay?
I mean, that's just kind of something we got to live with.
I never had that problem here in Frankfurt, but I did have it in Iceland because the hotel, everybody was crowded in the hotel. We were all under quarantine. And everybody was using the internet, so I couldn't use it. I couldn't even get on the internet sometimes.
Did you tell him it was an emergency?
Yeah. Okay, thank you. Anyways, dinosaurs are gone because they ran out of money. In a way, yeah. In fact, I think they called it in those days, you know, in the days of the dinosaurs, they called it what is it? No, they called it the Bitcoin. They called the dinosaurs biting. Okay, but in a way, you're right. You know, in a way, yeah. I think it's their money, their currency was food. All animals need food. Okay, among them, an animal called human. Okay, the humans, we need food, and you know, people are not aware, but everything we do every day, everything we produce, whether we produce something tangible like a computer or a car or whatever, or we produce some service, some abstraction out there, everything we produce on Earth serves only one purpose, and that is to trade it or exchange it for food so that we can live one more day. Whether you're Bill Gates or Bill Gatey, it doesn't matter. You trade it for food.
You could say we're all sick and we all need medicine.
Yeah, but medicine,
rice medicine.
if you're not sick,
I'm
you can.
I'm equating it with.
Well, yeah, in that sense, yeah.
In the sense we need rice to.
Yeah.
I'm sick with this stomach bug where I need to eat rice medicine or meat medicine or whatever just to keep living one more day.
Yeah, food you need. You don't need money. You don't need a computer. You don't need a car.
I need a computer.
But but what you don't even need love. You can be a hermit out there in the mountain for all we know. And certainly if you're an old individual, okay, you probably need less love and more health care. More doctors than love. But what we all need is food. We can't live without food, without water, air. Air is free, I think, so far. Nobody's bottled that. Water, they bottled it, but we can still get some from the river if you have a clean enough river. They do have clean rivers in Iceland. Not here in Frankfurt. I wouldn't drink from the Main River. But what we all need is food. Okay. So yeah, the currency of you can say the currency of the dinosaurs. They didn't trade. Okay, they didn't invent trade, but they needed to eat.
What does it mean for their currency to run out?
Well, their currency,
specific terms.
Their currency, like all our currency, is food. Ultimately,
So
we take it for
ran
granted.
out?
We take it for granted that food, I can get it at the corner supermarket, and it's like we don't pay attention to food first because it's quite cheap in general. Whatever money you make, if you're working, whatever money you make, you just go to the store and you buy it. And it's like you take it for granted. But it turns out that, someone produced it for money, someone distributed it for money. And if money is no more, for whatever reason, God comes in there and waves his magic wand and money is no more, that's it for man, because no one produces it or distributes it. So the issue is that all mass extinctions happen because the food chain collapsed. In our case, it involves money. In other animals, it doesn't involve money, but again, it's one of those things. Without food, for certain, you will die. Okay?
What does it mean that the dinosaurs' money ran out?
He was criticizing my theory, saying, so what happened? Did money run out?
Well, what is the theory, though?
Well, the theory is that food ran out. But he's saying, because I'm saying it's an economic collapse, he's saying, oh, what happened? Did money run out? Well, yeah, in a way, it's the money that they use, and it was food. And it turns out that our money is really food as well, but we are not aware of that because we have these bills or maybe even Bitcoin or some abstraction that we trade, and we always do it for food, ultimately. I mean, you can buy computers, you can buy cars, you can buy whatever you want, services, but ultimately, what we produce everything on earth is to eat and live one more day. Okay, so keep that in mind. Those are what I call the vitals, okay? Air, water, food, sleep,
temperature,
sex for some people.
Isn't that like the Maslow's hierarchy of?
Yeah, those are the
needs?
Absolute necessities, and that's where Mother Nature harps on. That's how she produces extinction, not through asteroids or volcanoes or anything like that. Okay, next issue. Let's move on here. You have it backwards. Oh, I'm so sorry. Okay, production creates money. Money does not create production. Production creates money because money is a representation of production.
As a side note, we'll answer all the chat questions at the end.
Yeah, I said that on the money. Okay, yeah. Okay, so what's the answer to this, fellow? Here it is. We can get this thing up there. Okay. And it's that production does indeed create money. No problem there. However, when humans invented money, production preceded trade. First, you had to have production. You had to produce something tangible in those days originally so that you could trade it for something else. So there was a production, and it was production for production. And that was the exchange. But today, this day and age, right, without money, we have no production. If God comes in with his magic wand for whatever reason and eliminates all money, and we do not believe anymore in money for whatever reason, then no one produces anything. Money is what keeps the whole chain of our existence alive.
So we're saying that it used to be that we produced first, like let's say way back then in hunter-gatherer times, or maybe after the agricultural times, production came first, and then since we had production, then we invented money to organize the production. But now it's kind of, you could say, gotten out of hand, where now we only produce to make the money.
Yeah,
We
now
put the cart before the horse.
things kind of changed around because now we produce only to get money. In those days, it was you produce something to maybe to get food or to get something tangible. I mean, maybe a guy traded corn for a table, for all I know, or some blacksmith produced a sword and gave it to you for some wheat or whatever. But today, we produce things, and even we're not even producing things, we're producing abstractions, and we trade them for money, which is another abstraction. And why? Because we want to have money, because with money you can buy the world. Okay? So we've changed that around. And the question is, today we're completely in an abstract world. Okay, another issue. Here it is.
No, we didn't talk about torque or light yet.
About what?
I'm just answering some of the questions.
Oh, yeah, we'll get there. We'll get to your questions at the end, okay? China is becoming the #1 world economy. It's happening right now as we speak. It will be common knowledge by the end of the 2030s, if we ever make it that far, okay? China is not going to take over the world, okay? We agree there, okay? It will be the financial capital of the world as it shifts from west to east due to the decline of Western republics devolving into oligarchies of career politicians and their cronies. That's a lot of politics, okay? And all I can tell you is give you my 5 cents worth. And that's that, yeah, I agree that maybe China might overtake the United States, the West, whatever you want to call it, economically. But you have to remember first that China depends on the West for its growth. That's one issue. The other issue is that even if it takes over economically, I doubt very much the United States will allow China to overtake it militarily, okay? And that's an important point to keep in mind, because that's taken us to a point where there's a crisis where China maybe expands economically to a point that the United States is worried about that so much that it creates a false flag, an incident like I showed the other day, and there's a war. We have not a cold war, we have a hot war. Okay? Just keep that in mind. There could be more involved with China becoming an empire than just economics. Okay? There could be military solutions. Okay, moving on here. Another issue that I want to raise, and that's this one. And that's that I always say you got to deal with Extinction 101 before you touch Extinction 102. At least, you got to show me that you know something about extinction, mass extinctions especially, before you talk about the extinction of man. Because the extinction of man is one instance of mass extinction, if that's how you think it's going to happen, which is what I think at least. And so first you got to tell me how past extinctions happen. What is the mechanism? And again, the homework helps you there. If you can tell me why the animals on land disappeared more or less at the same time as those in the water, you got a good clue of how they disappeared, why, what caused their extinction. That's one issue. The other one is you got to explain selectivity. Why on land itself some animals disappeared and others stayed behind. Okay. So just keep all that in mind. We do like for you to answer 101 before you answer 102. 101 is mass extinction. 102 is human extinction. It's a special case of mass extinction. And talking about that, here's one fellow who says, Extinction 101 never happened. We are still here. So I think he confused it. I think he was referring to 102, apparently, if he thinks that.
Or he's saying that there were no such thing as mass extinctions and they all just evolved into us.
Yeah, and that's a lot of people, especially religious people, they don't believe that there were dinosaurs and that those extinctions ever happened. In fact, originally when George Cuvier and some of these other, the founders of paleontology, came up with paleontology, they essentially started the discipline known as paleontology. What happened was, when they showed this to some of the religious folk in those days, we're talking about the 1800s, okay, the early 1800s, these people would look at those bones and they didn't understand anything about it and say, well, that looks like an elephant. had arthritis. So
It's a big elephant.
yeah, so they said just an elephant that died. That's all it is.
Really spiky teeth.
Yeah. So some religious folk, especially traditional religious folk, who believe that the Earth is maybe 7,000 years old or 11,000 years old, or whatever calculation they've got out there. They don't think that there were such animals as dinosaurs. And so you can't talk to them about a mass extinction because they don't even accept the assumption, okay, the original theory or assumption that led to that. Okay, and final comment on extinction. Here it is. Fellow says, read Pottinger's Cats to learn more about genetics and degeneration. It can be reversed, and Pottinger proved it. So he's saying that genetics essentially can be reversed. That's what he's saying. Well, let's find out. This is my answer to him. Okay, and it goes like this. Never use the word proof in science. Proof means that you believe something or someone believes something. So we don't use the word proof in science. In science, we explain so that you understand. Whether it's proved to you, it's been proven to you, whether you believe it, doesn't concern science at all. Then Pottinger did not prove you can reverse genetics, specifically species genetics. In other words, genetics at the species level. Okay? And then, without going too far, we have some people saying that Pottinger had an unscientific theory. Says in 1985, Pottinger's results were criticized for lacking scientific validity by these couple people here. Commented that Pottinger's study was overloaded with subjective observations and generalizations that render it unscientific. His overall inference was cooking meat made it unhealthful for cats, is contradicted by the fact that all commercial canned foods are cooked. Cat foods are cooked. Okay, so some people don't agree with that. What he did, what this fellow did, was scientific.
It wasn't proved to them.
So it wasn't proved to them. So these are so-called experts. I mean, if you believe in some of these experts or whatever, again, it's got to do with proof. And all we have are differences of opinion out there. And I don't have a problem with differences of opinion as long as the guy puts out a theory and says, well, I don't like your mousetrap. Mine is better. Fine, no problem. We listen to these two guys and everyone goes home, goes to his dark basement and reaches his own conclusions. That part is religion, belief. All we are interested in science is the explanation. Do you understand it? That's where science ends. What continues is religion. Okay, let me briefly go over. In fact, I have to go briefly over it because there wasn't much material in May because I had so much problems in Iceland with the transmission. Okay, so what was May all about? Well, it was about this. Okay, here's the summary. Okay, let me start with the summary so that we're all on the same page. Holy geometry. Some call it sacred geometry. What's sacred
Sounds
about
awesome.
it? Yeah, it really does.
Sounds amazing.
Holy geometry has no place in science.
What is that?
Well, here it is. I'll put a picture so that you know what holy geometry, sacred geometry is all about.
Better
Okay?
not be a tesseract.
No, here it is, okay? Here's people praying to the holy geometry. Some people will look at these and they see meaning in them. The one on the right, blue one there, well, that's the Mandelbrot set, okay? If you keep expanding upon it, you see more and more of the same thing over and over and over again. It's a question of it's an observer-related phenomenon where you focus closer and closer and closer, and you get these patterns that are supposedly mathematically created. Okay, again, nothing to do with physics, but people get hypnotized by these patterns, and they say, "Oh, I'm going to pray." They don't pray to God; they pray to the cube.
Yeah, it's like isn't this essentially numerology?
Yeah, it is in a way, and they call it sacred geometry. And so we don't care too much about that. Okay. Not part of science.
I mean, they use these things in like aesthetics too, like the golden ratio.
Yeah.
When they're making things like that.
Yeah, and
Things
people
things that are appeasing to the human nature, I guess. I don't know.
Or they look at 3 6s and they put it on the head of the devil or whatever. I mean, they have all these weird things. These are superstitions. That's all they are. Okay, next issue. what is it? A black, well, yeah, praying to the cube instead of the cross.
Oh.
Okay.
Okay.
A black hole is not an object. Okay.
Uh-oh.
What is a black hole? It's a singularity surrounded, which is a concept, a mathematical concept. It's known as a singularity. No volume, infinite density. It's a point. What is a point? Zero-dimensional location. Okay, etc. Non-dimensional location, actually. Okay, so black hole is a singularity surrounded by an event horizon, a region of influence, you could call it. Okay,
A concept surrounded by a concept.
there you go. To summarize, right? Therefore, it does not qualify as a figure for the purposes of geometry. It's not an object. It's not a thing. There's no such thing.
Aristotle wouldn't have liked the black hole.
And Aristotle really followed by Mr. Euclid. Let me get that for a second out of here so we can see you. Aristotle followed by Euclid. What did Euclid say? Well, he says that an object is that which has a boundary. And what is a boundary? A boundary is that it ends in an object.
Sounds like he's talking about shape.
Well, he's talking about a circular. He's got a circular set of definitions.
But that which has a boundary sounds like he was defining it as that which has shape.
Yeah, it is, and that is, and if he would have stopped there, he would have been okay. But then he said, "Well, let me define what shape is. Let's define what a boundary is." And
Yeah.
what he says, a boundary is the end of an object, the end of a shape.
Well, I mean, how else are you supposed to define it?
Well, you're not supposed to define shape because, again, and people sometimes have trouble with that, especially people whose religion gets destroyed by the definition of an object. They have a problem with this. What is the problem? The problem is we do not have to define the word shape in science or in physics. What we need to know is the difference between, or distinguish between, shape, motion, see, touch, mass, volume, which are the choices. What choice, what criterion are you going to choose to define the word object for the purposes of physics? Are you going to say that which moves, that which has location, that which has mass, that which you can see, that which you can touch?
All of the
or are
above.
you, well, yeah, and some you can't see. I mean, I can't see.
Some of the above.
I cannot see the table that I have in my head. So is the word table an object? Okay, so we have a problem there. We have to define it in such a way that we encompass all objects in the universe, the words that represent objects. And for that, there is only one criterion, and that is shape. You want to know what shape is? Go to a kindergarten and find out. They'll tell you what shape. The kids will tell you what the difference between a cube and a sphere is. Okay, and so let's continue here. The other issue is quantum electron is not an object. A quantum quark is not an object. A quantum gluon is not an object. If the quantum hydrogen atom is made of electrons, quarks and gluons making the proton and the neutron, by the way, then the QM, the quantum mechanics atom, is not an object, is not a figure, is not a part of geometry. But they use the word point. They talk about the the electron being a point particle, an elementary particle, a fundamental particle, okay? And so here is, let me show you that. Here it is. This is the definition that you find out there, okay? What is an electron? Are generally thought to be elementary particles because they have no known components or substructure.
They're not made of anything.
Right. And what is an elementary particle or fundamental particle? Is a subatomic particle with no currently known substructure. It is not composed of other particles.
The currently known part, that's for job security.
yeah.
We're still
investigating. We're still trying to find what all this stuff is, right? Okay, so this is the problem. The problem is that, what do we have today from quantum mechanics? Electrons, point particle, elementary particle, fundamental particle. So is the gluon, which is mediates the strong force between quarks, three of which constitute the proton, also neutrons, by the way. 2 ups, 1 down, 2 downs, 1 up, whatever, it doesn't matter. The point is, you got 3 point particles mediated by countless gluons, which are point particles, and what orbits them is a point particle. And they're all zero-dimensional, no volume, elementary particles, not made of smaller particles, meaning they're the ultimate, that's where the buck stops.
That we know of.
That means it gives them job security to find out what they're made of.
Yeah.
And for that, they say, well, you need an accelerator the size of the orbit of Pluto. So good luck with that whenever we build that one. I don't know how many pesos that's going to cost us. Okay, so let's move on to the questions that people made. Okay, so let's go with the first one. And then we'll get to the questions real time here. Sorry it takes a long time, but I do want to answer questions that people make that follow us and that are on topic. Even if they throw stones and rotten eggs in my face, no problem.
I mean, sometimes I just worry that we answer it too quickly, maybe.
We do what we can with the time we have, okay? This is not a 24-hour show.
Okay? Sometimes to answer a question, like for the person to really understand it, you got to go way deep.
Yeah. And sometimes I turn those into lectures because I realize that you need a little more comprehensive answer, okay? Okay, so one fellow says, what do you think of category theory? What the hell is category theory? Well, briefly, it says category is embarrassing. This is one fellow that wrote this on the internet, okay? Embarrassingly simple concept. A category consists of objects and arrows that go between them. Okay, so you see objects there and two arrows that go between them. Okay, what is this guy talking about? What the hell is this? It says that's why categories are so easy to represent pictorially. Okay, an object can be drawn as a circle or a point, and an arrow is an arrow. Okay, that's very enlightening. Okay, but the essence of a category is composition, or if you prefer, the essence of composition is a category. Great. Learned a lot so far. Arrows compose, so if you have an arrow from object A to object B and another arrow from object B to C, then there must be an arrow, their composition, that goes from A to C.
What is he talking about? What's the context?
Well, this can be used, they say, for physics, for programming. They've got mathematics. There's a lot of fields that use this notion of category theory. But let's continue. I'll try to get to some of these points. In category theory, there you can see it. If there's an arrow going from A to B, an arrow going from B to C, then there must be an arrow going from A to C. Okay?
Sounds like stamp collecting.
Yeah, so far we have not explained anything. All we have, if anything, is a description. Okay,
or a method to categorize.
Yeah, so let's see first what these objects that this guy was talking about. Here's the objects, okay? Did I get that right? Yeah, okay. And so these are the objects, okay? The objects are right there in the center. I circled them or, put a red square around them. Sets, groups, mathematical groups, okay? Spaces, vector spaces, etc. Smooth,
measurable spaces,
manifolds, What is all this? All these are the objects. So what are they talking about? Well, they're talking about math. That's what they're talking about. Objects of math, mathematical objects. What the hell are mathematical objects? But this is what they're talking about. And so here's my answer to that, okay? So that we can cut through the rubbish, okay? Here it is. Let me put it on my side this time, or I'll cover your face, you don't mind?
Oh, that's cheating.
Yeah. Okay, so this is category theory, okay? First of all, it's not a theory. Theory is an explanation, not a description. What these people do are described. What and how they describe mathematically. They're not talking about objects, real objects. They're talking about mathematical objects. What is a mathematical object? It's a concept that the mathematicians turned into an object or treats like an object. And he moves around, he puts arrows, I say, oh, A goes to B or C. No, A could not have gone to B or C because both A and B and C are concepts. They're talking about what? What were the objects? Groups, sets, spaces, manifolds. What the hell are those? I don't know what those, please draw it. I want to see a physical
like a pile of apples or something?
No. And what they do is they represent them like this guy said at the beginning. They represent them with circles or with objects. So they represent love with a heart. And they point an arrow from heart to head, to mind or to head or whatever. And they say, I've united these two objects. No, a heart maybe, but not a love. You can't join love with mind.
Sounds like it's like coding language.
And they do that. They use this.
But if we're talking about coding, then if we're just talking about the actual objects, it's the hardware.
Yeah, but they're not. What they're talking about again
That's
is
the actual
concepts.
objects.
Right,
There's no
right.
such thing as like when I'm
Mathematical object.
Yeah, there's no such thing as a mathematical object. That's just a concept that we extract out of the hardware. Like
Yeah.
the hardware is doing a lot of complex stuff. We don't talk about the hardware exactly, which flip, which zero, which one. Even the zeros and ones don't count. It's we're talking about where the electricity is going in the circuits. That's the actual thing.
Physical.
That's the actual physics and objects that are being represented on screen.
Right.
But the
right.
concepts, if I say A equals 3 on the computer, like if I'm coding, the electronics are doing something, like there are actual physical changes happening in the circuitry, but we don't talk about the actual objects. But that's I think what this person mistook.
No,
They mistake the map for the territory.
That true, but the issue here is that they talk about mathematical objects, and there is no such monster as a mathematical object. They're using the word object so that they can replace them with real objects or images, and they say, okay, I moved object A from X to Y. And what they're really talking about is concepts. They're not moving objects, but they think they are, and they treat them as if they are. And what is useful is to develop technology or to do math or to do programming. For that stuff, it's useful, okay, because these are concepts that are useful in those fields. They have nothing to do with physics. Physics, we have to explain real mechanisms, why pen falls to the floor, and I'm not going to do that experiment for the millionth time here.
I got it.
Okay, you got it? Okay, there we go. Okay, so we need to explain that. And that's got nothing to do with mathematical objects. Okay, next issue. Fellow says, says, what do you think about the video, Does the Higgs Boson Exist? By Sabine Hassenfelder. I'll be brief on this one. I think I need to give another lecture on Sabine. Okay, but today we got to cut it short. And this is what she said in that video. I pulled it all out, but I'm just going to look at two things here. Okay, and it's because this is what she was addressing, whether the Higgs exists. Okay, so the issue was the word exist. What does it mean to say exist in mathematics or mathematical physics, which is what Sabine does? Well, it says this is what we mean when we say quarks exist. We mean that the predictions obtained with the hypothesis agree with observations. And she says that the same story is for time, and she goes on explaining that. And then in a follow-up video, she says more or less the same thing. To summarize, the last square there, to summarize it briefly, something exists if it is useful to explain observations. That's her definition, their notion of the mathematical physicist. And of course, this definition cannot be used in science or in physics.
Very Swiss cheesy. I could tear that one down.
Absolutely. It's very easy to tear down her notion of exist. But see, the issue is that they use that notion because they don't care about physics. They care about mathematics, and they care about, the equations related to mathematics and what they can describe and measure. And so they don't care about the real physics, the objects, the things. And so that's why they give you an irrational explanation. And we say, and she says that in there, she says well, this is what we think, this is what we mean when we say that the Higgs exists. And she says, well, what if you have a different definition of exist? Well, for that, you have to go to the philosophers across campus. You got to go somewhere else because they might have a different notion of what exist means. And this is our definition. This is what we mean by exist. And they're going to stick to that even though it's an irrational definition. They cannot defend it, but they'll stick to it because it's for their discipline. Okay, it's what helps them in their world. It has nothing to do with physics.
The bottom line is they're not interested.
They're not interested
in the definition of exist
because they're not because the definition of exist relates to qualitative type of answers. It has nothing to do with math.
Well, they're just interested in I think the problem with math is they're too interested in relations. They're only interested in the relations that objects have with one another.
Yeah.
Not the objects themselves.
Yeah, and so
they're interested in the effects, in the relations, how long is the table? I don't care what the table is.
Or
how long it is.
Yeah, what it does maybe.
They extract all the numbers they can out of it, and then they use the relations for things.
Yeah, and so what happens is they can't give you a physical interpretation. When they give you a physical interpretation, 150% of the time of these invisible, intangible entities or mechanism, they give you an irrational explanation.
Well, it's just a metaphor.
Yeah, no, and they say, well, you didn't like that? Go to the philosophers. They deal with that stuff. We don't deal with that. We deal with just descriptions, mathematical descriptions, and that's what they equate with science. And that's what everybody gets taught in high school to believe is science. It equates with science. Okay, and that's where the problem is. That's why science is not what all these people have been doing for 2,000 or 3,000 years. Science is an explanation. What people want to know, the common man wants to know, is, what is gravity? Why does the pen fall to the floor? And once he understands that, he doesn't care about all your math, all your equations, all your measurements. That's stuff he's not interested in. That's why 99% of humanity doesn't pay attention to physics. They got bored with all this nonsense of black holes and Big Bang and all that stuff because...
Well, if you watch any physics person explaining something, quote unquote explaining, it's usually like, let's say giving an interview or something, usually what they do to sidestep things, not that, I don't know if they think about it as sidestepping, not necessarily, but essentially what it boils down to is whenever they're trying to give any like physics-y explanation, it's usually just kind of fun facts. Like, did you know the universe is 7 billion years old? And you're like, whoa, and then you're thinking of that, and you're not. And he didn't answer the question. He just gave you these fun facts, like, oh, you know what happens at the edge of a black hole? Holy crap!
Or how fast you fall into a black hole.
He just tells you, but they tell you these things like they're already true.
Yeah.
Like one of the things I saw was a kid asking, I think it was Neil deGrasse Tyson, what happens when two black holes collide?
Yeah.
Like it was like a little kid in the thing. And first of all, he went off on all these other tangents, and then he just goes into like time starts bending into itself and things like that. And you're just like, whoa, dude, that's crazy.
Bend time?
Yeah.
I can bend a clock, but I've never tried bending a second. It's very hard. I tried, but too strong for me.
But it sucks because it takes all the like reality out of.
Yeah, because when people hear that, they say, "Oh, okay."
It's magic. It's essentially.
Well,
magic.
no, they walk away because they say, "I didn't understand squat."
Yeah, they don't understand it, but they're like, "Oh shit, man, the universe is mysterious. It's like magic." Oh well,
it's mysterious.
But they take all the reality out of the most real, what do you call it? Subject. Physics is the most real subject, essentially.
But that's why people lost interest in a lot of that because they listen a little bit for a while. They say, "Okay, so the universe is 14 billion years old." Oh, okay, great, and they walk away. They're done. They don't want to hear anymore because they heard it 1,000,000 times and they say, oh, but we have proof and now we confirmed it to a more accurate value. And, people don't care about all that stuff. They say, okay, it's 14 billion years old. We got it. That's it. That's the end of physics for that person. Okay. Another fellow says, can you explain the mechanics of removing the electron from silver halide when light hits the film?
Well, that was one of the questions in the chat.
Oh, was it? Oh, okay. Well,
here we are.
Someone asked it last time, I think. Asked it. Well, let's find out. Silver halide is one of the compounds formed when silver and one of the halogens, silver bromide, chloride, iodide, etc., mixed with silver. Okay, so those are, and they use typically what they say is a pseudo-chemical notation, which is Ag, which is silver with X. It could be any one of those compounds. Okay, when absorbed by a crystal, a bromide or whatever crystal, photons cause electrons to be promoted to a conduction band. What does that mean? Well, it means that when you have a light, this is more or less Compton's effect. It's more or less the photoelectric effect. That's more or less what it is. What is it? Light hits a film. In the case of photoelectric effect, it's metal. Here we're talking about emulsion that has little crystals of bromide or chloride, whatever of these crystals in this emulsion. And what it does, it according to quantum, okay, so this is the quantum version first, okay, it supposedly hits an electron bead. Remember, the quantum atom is a little proton. We're going to go with a simple one, the hydrogen atom. It's a proton. It's got a little electron going around. Okay, so it hits that electron somehow. It's got very good accuracy, very good precision. Hits that little electron.
Found it, sniped it.
Yeah, hits it out of its orbital, puts it into conduction band. In the case of more complex atoms such as iron, it'll hit one of the ones on the outside and hits it into the conduction band. What does it mean? It means that the electron now is free to move around the film or the emulsion in this case. Okay, and so it moves around. What happens? The film, this emulsion, is not completely uniform. It's not perfect film. It's got these crevices and indentations and so on. And this electron bead, apparently, according to quantum, right, falls in there or gets stuck in there. And then another electron, because remember, the light is hitting all these electrons. Then another one gets stuck, another one gets stuck there, another one. What happens, it builds a little seed. Okay, and from that seed it grows, grows. And you create this tiny film that somehow can reflect light better. Okay, and that's why these photographic films have this material in there, because it's a material that is amenable to forming seeds which grow and then can reflect light better. And that's why you get a better image from, these types of materials. Okay, so what I can do is give you now the brief version, okay? And so I want to compare. First, let's go with this. This is the version that another guy has of what I just explained. Essentially, you have that the crystals there, the little circles, and they're in this emulsion. Light comes in there, that yellow thing. That's light hitting it. Okay, high frequency light. It hits the electron, which jumps out, okay, of its atom, and they accumulate where you see those. What do we call them? Those lightning bolts. Okay, so those are imperfections in the film. So they accumulate there, as you can see on that on the right-hand side there in the middle. Okay, they accumulate there, and once they accumulate, they form this seed, and from there, what you have is an ever-growing region where you have high reflectivity. Okay, so that's in general terms the mechanism that happens during this halide thing. Okay.
So we're shining light on a silver halide emulsion to make it shinier.
And you make it shinier by the explanation. Quantum explanation is you're hitting the electrons, forcing out of the first.
They continue into the crevice. They all continue into all the crevices.
They build in there.
Then
they
in
build
those
up.
crevices we have a layer of electrons which reflect light better.
Well, what happens is the electrons bunch up there, and supposedly because they're negative, they attract ions. Okay, so they recombine. Okay, and they form these atoms, these regions where there are a lot of recombination of atoms, of the right kind of atoms, and they form this reflective film in there. That's essentially it. But we're not interested in the technology, so I'm not going to go into technology. We're interested in the mechanism, which is essentially what this person asked here. They want to know the mechanism, okay? And in science, we don't care about technology. We care about the mechanisms. That's what we try to explain. Okay, for this, you have to understand, again, here's the photoelectric effect, for which Einstein won his Nobel Prize in 1921. He was able to explain it using, what's his name? Forget it. The guy at the turn of the century. I'm getting old.
Yeah, that's what I was going to say.
Okay, I'll remember his name in a second here. Photoelectric effect, what is it? You have light shining on a metal film, polished metal film, and the electrons start flying out. Okay, and the electrons flying out, that forms a current. Okay.
Flying out or along the
along the metal. So this is a very simplified version. Yeah. But the point is, photons coming in, hit electrons, and the electrons start flowing. It's a current, and that's why when you shine light on a polished metal film, you create, a current. Yeah. I was thinking of Max Planck. Sorry. Okay, so that's more or less what's happening here in general terms. Okay, so here I'm going to show the Compton effect, which is almost identical. In fact, I think it's the same mechanism. What is the Compton effect? Again, you have light coming in, hitting a film of some kind. Doesn't matter. We're not interested in technology. Hits a film, and what happens is, on the one hand, you have current, and on the other, you have light coming out. But light comes in with high frequency because those balls, quantum, hit something solid like an electron. It loses energy, frequency, and so the electrons form current in one direction, and in the other direction what you have is light coming out at a lower frequency. That's the Compton effect.
Basically, kind of like a Newton's cradle. It hits the ball at a certain speed. This one slows down, gives it to this one.
More or less like that, okay? And in one direction you have light at a lower frequency, right, than the one that came in.
Another
because
photon
because it hit a wall, right? And I'm sorry.
Another photon shoots out the back. So if you shoot light here, a lower frequency photon is supposedly shooting out the back.
Yeah, and here you'll see it, and here you'll see a comparison, a side-by-side comparison of the Compton effect, which I explained the other day. But it's more or less what this person is asking. In other words, what is the mechanism from the point of view of the rope model versus quantum mechanics? So we compare them side by side, so we get an idea here. Okay, and here it is. The one on the left is the quantum. Okay. And what you have is coming in, those yellow balls that you see on the left-hand side, that's light coming in. Those are photons. And you can replace those with waves if you want. Transverse waves. So it doesn't matter. What we have is light coming in. It hits the atom. What does it do? It strikes an electron and it moves it to the conduction band. What does that mean? It means the electron is free to flow. When you have lots of light coming in, hitting lots of electrons, what you have is an electron current that flows. But because the light coming in had high frequency and hit an electron, what you have coming out is a low frequency light or long wavelength light. What is the mechanism under the rope model in comparison, just side-by-side comparison there? We don't have light coming in the sense that something hits the electrons. What you have is the torsion of the ropes. So I put one rope there, but you have to think of that as gazillions of ropes stuck to gazillions of atoms that form the film that you're hitting light against, okay, so to speak. And what it does, because the torsion is at a high frequency, it compels the merged electron shells that form the film to torque as well, to rotate. That rotation is what we call electricity, current, whatever name you want to give it.
Rotating electron shells.
Yeah, and then what you have in another direction is light. But light, because it was stopped by the effort that the ropes expended in moving the film, the light coming out comes at a lower frequency or longer wavelength.
So the torque comes in, spins the atoms,
loses torsion.
But the electron shell around the atoms.
Yeah.
And the electron shells.
Remember the electron shells.
That
right, but the electron shells, remember, are merged. Okay, so they're merged. Okay, so they're bound to each other. They're also aligned, etc. And what you got coming out is lower frequency or higher link length, as we call it. Think of it as wavelength if you want, coming out.
There's a lot of spinning involved there.
Yeah, so that's the comparison. Do you believe in it? That's your problem, okay? We explain so that you understand the difference. What you conclude is your own...
The gripe that I have with that theory...
You have a gripe.
Yeah, I'm here to shit on you. Is if you have many ropes converging on one atom, if you only have one rope and one ball, if you spin the rope, the ball turns. That makes sense. But if you have many ropes coming into one ball and they're all spinning on their own, why would the ball spin? Wouldn't just the tips of where the rope hits the ball spin?
Well, remember, you have a row, and you have light coming towards the row head on. So the whole row spins.
Yeah, okay? but if you have a ball,
I know.
You have many ropes hitting the ball. Let's say two, just to make it simple. If you have two and they're both spinning on their own, why does this ball spin? Or not the? I guess the ball. But I guess the ball in this case isn't a ball. It's a ball of string.
First of all,
you get what I'm saying, right?
Yeah.
One
more
rope,
than likely,
this one spins, right? But if you have two ropes and they're each spinning on their own, why would this one spin?
Yeah. The first thing we have to remember is that typically it's not atoms. We're talking really about molecules. Okay, so we're talking all these atoms, all these films. For example, metal. You take a strip of iron, and all the atoms are more or less aligned to some degree, but when you hit it with something like light, they do become aligned immediately, and they're easy to rotate in the case of iron and some of these conductive films. And what happens is when you come in there, they immediately start spinning when they hit when you hit it with the right frequency light or a high frequency light. And what he's saying is, well, what if you have gazillions of ropes and they hit the atom not exactly in the center, but they hit them all around. So you have like a beam hitting the atom, the first atom or the first molecule, if you wish, whichever one, and you're hitting it all around the electron shell. So you're not hitting it in the center and having it spin like you would spin maybe the little balls that form an abacus, okay? That you can't pass your hand and they all spin, right? But if you had many wires, then you say, well, why do they spin? Well, the issue here is, and this is something very hard because another guy asked this question, we're going to get to that in a second, and that's that when the electron shell spins, it goes right through the other rope that's on the side. And people have a problem with touch and see, and we'll get to that in a second.
Well, I think one big thing with the electron shell that even I keep forgetting is it's not a ball. It's ball shaped, but it's a series of many threads. Yeah, it's essentially fluid. You can almost consider it.
It's also, remember those the atom is moving back and forth in different directions along those ropes. That's one issue. The other one, it's vibrating and it's expanding and contracting. There are several motions to an atom simultaneously. And so you got to get that. It's very hard to picture. Believe me, it's even hard to draw. But we have to conclude that from the Mossbauer effect, which is non-recoiling atoms in a crystal lattice. You have vibrations. You have expansion and contraction, which is the quantum jump. Okay, so there's several motions to an atom. You know, and you're talking about something extremely small. We cannot imagine how small that is, let alone the rope that is much smaller and thinner still. But you got to try to be Atom Man and try to see if you can get your mind into that little tiny world and just try to visualize it. That's all you can do.
Did the theory of the rope model or the rope atom, you could say, start off much simpler, and then you had to keep accepting more and more assumptions like the Mossbauer effect, and then it has to have this motion as well, and then this motion, and you started adding them on as you kind of accepted assumptions?
Yeah, but see, it happens
to explain certain things, you had to add this motion to the atom.
Remember that throughout, at least in the last 400 years, you had all these researchers, these theorists throughout time. You had Faraday, and even before then you had Arago in France and so on. They studied all these things and they kept improving on the previous generation. And they said, oh, but this guy was wrong, we found something different. And they kept discovering more and more properties, but they never zeroed in on the things themselves. They tried to analyze them mathematically, they described them mathematically, they had the proper equations for the effects that these invisible entities caused, but they never zeroed in on the entities themselves. That's why they had to invent this wave. You know, what is a wave? What is a transverse wave?
It's like a patchwork answer. Whatever. We're more interested in the effects of the whatever this is that we call light. We don't really care what it looks like, what it is.
If you take James Maxwell, he came up with great equations. You know, he did enlighten us regarding the equations, the behavior, but he never figured out what was the object that was in there. Okay?
And he was studying all this stuff.
Yeah, and so, well, let me move on here, okay?
We still got a lot, damn.
No, but I'm just going to skip a lot of some of the extra explanations that I was going to give, but I got to skip because of time. Okay, how can light be physics if what you call light is math?
Oh boy.
Okay, I'm not sure I understand the question, but here's my answer.
Light is math.
Let me get these out of the way here, so I don't get them confused. Yeah, here. Okay, so let me answer this gentleman.
Light is math.
So here's the answer. Light has two components, okay? or aspects.
I like this.
One is a physical mediator, and the other one is what it does. So there's two aspects to light.
I like that.
So we have the mediator in quantum. They use the particle or the transverse wave. Okay. In the rope model, we have the DNA-like rope. So that's the mediator. That's the thing. Okay. And then we have what it does. And in QM, quantum mechanics, we have one-way straight line itinerary in the case of particles, right? And in the case of the transverse wave, we have this up and down oscillating motion, okay? Which is an up and down itinerary, essentially. In the rope hypothesis, what we have is two-way torsion, okay? And that's a little different than quantum mechanics, okay? So we have to distinguish, not say it's math, because math is just a description. Well, we have to find out what is the object and what does it do. Those are two different things. What they figured out what it does. That they had no problem. But they never figured out what it is. What is it? And we have this issue where they say, well, light does not need, and listen carefully to the wording here, okay? Light does not need a medium through which to propagate. That's not the question. That's not, the mathematicians are answering the wrong question. The question is, yeah, light can go through water, light can go through air, light can go through vacuum, through nothing. No problem there. We're not talking about the medium through which light can go. We're talking about the medium that light is itself. We want to know what light is. And people say, well, light is nothing. Well, then you have the movement of nothing. Because if you're saying that light travels at 300,000 kilometers per second, what is it that's traveling?
Yeah.
So forget about the medium through which it's traveling. We're concerned about the medium of light itself. What is light? What is vibrating? What is traveling? Yeah. That's the question. That's the question the mathematicians never answer. They go and answer the question nobody asked, which is, what is the medium? It doesn't need a medium through which to travel.
But that's a common one. They answer a lot of questions
that you didn't ask. I didn't ask that question.
I didn't ask that question. Yeah,
but we answered it.
We answered it anyway. We'll do a pro bono. You can keep this one.
Okay, another fella asks.
You need a better system to raise those up.
Yeah, it takes time to raise them from all the way to the bottom. With respect to the rope hypothesis, how can torsional waves be polarized? I didn't understand the explanation given in the book. I don't know what book you read, but nowhere that I know of I've ever written anything about what torsional waves. In fact, I specifically state that there are no such things as waves. Waves is a verb. So until you can phrase your question in a scientific, in a physical sense, I have no idea what book you read or where you got this, okay? So no, we don't have torsional waves, whatever that means. I have no idea, okay? You got to rephrase that in a scientific manner. Okay, let's move on with another issue.
So we just didn't understand the question?
Yeah, I mean, I don't know what torsional wave is. I never used that in my book, so I don't know where he got that. Maybe you can quote the passage in the book so that I know what exactly you did not understand, because you're saying you didn't understand the torsional wave, and I don't know where you got that, because I don't understand torsional waves either. Oh, got the wrong one there, see? Got the dinosaur eating. No, it's the Bytecoin. Yeah. The Bytecoin. Okay, one guy asked something related to link length, okay? He says the following, he says, so when an atom pumps its electron shell, quantum leap, right, it releases a link or wave of light, yeah? If the wavelength of light is a meter, then does that mean that the electron shell expanded to a meter? Very good question. Love you. Very good question. Finally, one that is scientific, okay, one that makes you think. Okay, I'll give you my 5-cent worth, and these are the things you got to look at to zero in on that question. And I'm not saying that I've got a full answer for that. Okay, I'll just give you the best answer I got, and these are the things that you have to consider for that. Okay, and so let's go one by one. The first one is visible spectrum versus the radio frequency spectrum. You see it down at the bottom there. You can see the visible spectrum is very tiny compared to the full spectrum. In fact, I don't think it's very well set up. I think the full spectrum is much longer than the visible spectrum. Very small part of the spectrum, of electromagnetic spectrum, is visible. Cold atoms pump slower, okay? In fact, someone asked about, and I think I've got that question there as well. Someone asked about, quantum computers, and they have a lot to do with cold, trying to make something work under certain temperature conditions, okay? And all I'm saying is when you have a cold atom, okay, what you have, you're producing low frequency, low energy, and longer wavelength, which under the rope model means that, well, I'll show you a picture in a minute, which is you have, better see it here. High frequency means many links, and each link is smaller. And low frequency, few links, and each link is longer. Okay, so that's essentially the notion of low frequency, low energy, high energy. Okay, that's the model from the rope model, from the rope hypothesis. Quasars are distant objects, and they emit radio waves. In fact, originally when they detected them, it was through radio waves. They said, what are those things? These are so far away, the farthest objects in the universe, they're pinpoint. They form apparently the center of galaxies, and they emit radio waves. And that's got to do a little bit with the redshift. The redshift means that people think, in other words, the mathematicians, not people, mathematicians think, that redshift means that something is receding from us. Okay, and that's how they determine whether the thing is coming towards us or far away. If it's coming towards us, it's blue shifted. If it's going away, it's red shifted. Not true. Not true. The issue here, let me take that out so that we can see your face at least, right? I can't even see your face now. Let me get that one out. What is the issue? The issue is that if you take a rope, any rope, okay, in fact, let's show that. Yeah, you take a rope and you tie it to a wall and you go to the other side of the universe, okay, that rope, as it goes towards you farther and farther away from the source, okay, the links will become longer. So a longer link is a red-shifted, that's how we would detect it, as redshift. And a shorter link will detect as a blue-shifted link. It can have to do with whether an object is approaching or receding. For example, the Andromeda galaxy is approaching us and is blue shifted. But not all objects that come and go are red shift and blue shift. In the case of quasars, they're so far away that every rope that comes from a quasar to our eyes or to our telescopes or whatever we use, their radio detectors, what we're detecting is an object that is so far away that the ropes have become longer linked, and that's why they're red shifted. And it turns out that just by sheer coincidence, the far away objects are all red shifted. And so what these people have misinterpreted is that, oh, that's red shifted because it's flying away from us. Not necessarily.
Are there any really...
Could be, but not necessarily. They could be coming towards us, but the rope is so
tired.
Yeah, it's called tired light.
Yeah, I imagine.
And it's so untwined, and the links are so long that they're red shifted.
Are there any really far away galaxies that are blue shifted?
That's a good question. And they try to match them with CFeed variables, but that's a long story. They don't know because they only have one notion right now for blue and red shift. And they think it's only related to motion.
Does that become a problem because they start interpreting and also passing on information with the interpretation that all red shifted things are going away? So you can't really tell. Is that how they determine distance? How do they determine distance?
And one of the guys who criticized that was a fellow who died a couple of years ago, Halton Arp, and he criticized all that redshift stuff. He was an astronomer, and they kicked him out because he said all these are not redshift. Blue shift does not just mean motion. It could mean distance. He had another explanation than me, but the point is, you can't just go with one interpretation. You got to listen to all the theorists out there, and well, you choose the one you want. It doesn't mean you're going to silence the guy, which they did. They kicked him out of the States. Essentially, they didn't give him any telescope time, so he had to go to Germany and and do his stuff there. But again, you got to listen to all these theories because they might click something in your mind, and that's the value of science, of making you think and you reach your own conclusion. Believe in whatever you want. You can believe in God if you want. Okay, let's move on here. One fellow says, we'll go quickly with these. Says, there are no ropes as such. Did you look at the pictures you showed? No ropes. Well, yeah, you can't see the electromagnetic ropes. The electromagnetic rope is what you use to see. Okay, so that's the way it works. And here I've got a little gift here, a little drawing. And here I put 5 atoms, 1 per finger. Okay, and they're approaching a ball, and I'm just looking at 1 atom per finger connected to 1 atom of each of the ball, right? And so as the fingers move towards the ball, they're sliding through the ropes.
That's trippy.
And so when you slide through the ropes, you can't see the rope itself. It's like saying, look, I've got a bead on the abacus, and the bead on the abacus is sliding through the wire, right? Well, does the bead ever touch the wire? Yes, it does, because it's made out of the wire in the case of the rope model. The atom is eating into the rope because the rope, the threads of the rope form part of the atom. So the atom touches the rope, but at the same time it can never meet up with a rope because it can only meet up with another atom further down the road, because that one it hits against, but it cannot hit against the rope because it's sliding through the rope, because the rope is part of the atom. It's the 2 threads make up the atom.
Hold on, as a side tangent.
Yeah.
Crazy side tangent. Does that mean that if you have a ball, take any object, existing, like this thing. Let's take, I don't know, whatever, this pen. This pen is never made of the same thread, because over here now it's a different set of threads. All the atoms just abacused around, and the thread that makes those atoms snaked through.
Slide through.
Yeah, slid through. So essentially, if you're moving, this is different part of the ropes.
Yeah, and remember something. Depends on if the ropes are crisscrossing the universe. You can't move those ropes. You're sliding through them. But then you have objects which are nearby. Okay, and now that's a little different. Okay, perhaps. So you might have two situations. One where the ropes which are close by, it's like, you got a fishing rod. Okay, and you got the fish very close by in the pond, and you can pull that fish through that rope. But at the same time, if you have your fishing line going through the earth all the way to China, okay, it's just crisscrossing, and you just happen to go through that rope, well, then you're just sliding through the rope. So you can have 2 motions, and again, this is something that needs to be looked at in more detail. Okay, I can't tell you which is a case. Yeah, it is complicated because you're talking about something you can't see. You just have to imagine and find out how it could be working. Okay? Yeah. And so I can't give you a straightforward answer to all these questions. I can just tell you what to think about because I don't have a solution for every little thing.
But again,
I admit that. But
it's
all I can do is give you what goes through my mind to try to explain that phenomenon.
But it's a direct correlation. If we're assuming that that all the atoms here abacus through rope, then the matter, assuming we're calling matter the threads / ropes, then it's always different matter that comprises.
Yeah, it's different rope or different thread. But that could be from the ropes that are crisscrossing the universe, or that you're going through, and then there could be other ones like maybe the moon, for example. The Earth spins the moon around, but what? Through the ropes that connect the atom from the Earth to the atom that ends in the atom in the moon. Okay, that one is short distance.
The ones that go through.
The ones that it goes through, the moon goes through ropes that crisscross the universe because they go from matter on one side of the universe to matter on the other side of the universe. those they go through, and those are, you know, more or less like the radio frequency. The fact that, you know, in fact, I did not finish that for lack of time, but radio frequency, you know, you can't have two people on the same radio frequency. And again, what ropes are you stimulating? Well, you could be stimulating ropes that crisscross our region. That's why they're RF. They're long wavelengths, right? And what happens is I can get on that wavelength, but you can't, because if you get on that wavelength, we're both interfering with each other, because these are the ropes that crisscross the universe. Okay, maybe you can affect maybe the the amplitude. You can affect maybe the frequency, but only one person can get on that wave, because otherwise, you know, we're two people on the same rope, so to speak. And so these are the things that need to be ironed out. I'm not saying that I've got an answer to all this. I'm just saying that these are the things I think about when I look at this and try to explain it myself, you know.
But the universe under the rope model sounds more like the Matrix.
Yeah,
like,
it is a Matrix.
Like when you see it, like it's kind of when Neo sees the Matrix, you see all these lines crisscrossing everywhere.
Yeah, there you go.
Like, if you could see the ropes, you'd go insane.
Yeah, it'd be Matrix
everywhere.
I mean, thank God we can't see the rope.
Holy shit.
Okay, and here is another. My question. Fellow says he's a little angry at me. He said, my question was not about C-touch criteria. You converted it into C-touch criteria. I wanted to know that when magnetic threads spin, it doesn't what? Clash. Clash, 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 clash. That's what you said. Clash and blah, 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 blah. I didn't complete the sentence.
It doesn't clash?
Yeah. Why when the rope goes or crosses or whatever the thread, he said, why don't they clash? And so, yes, he's talking about C-touch. He doesn't even know what he's asking. Okay, so he is talking about C-touch.
I guess this person is making a distinction between clash and touch.
And there is no difference, because we look at the definition of the word clash.
Yeah.
That's the word he used. Okay, I'm going to use his word. And it says clash, to come together or what? Collide. We're talking about touch.
They should have specified what they mean by clash then.
Well, that's what I'm saying. You got to make your, if you say that you're not talking about touch, then don't use the word clash. Talk about something else.
The word clash is kind of synonymous with touch.
Yeah, it is.
Clash,
but he doesn't realize that.
Well, I mean, yeah. It's just
again,
something got lost in the translation.
People don't understand what they're asking. Yeah, you're talking about
maybe
touch.
He's got a real question, but
but then he's got to rephrase. He's got to rephrase it so that. I mean, if you're talking about clash, you're saying, why doesn't the rope go the thread, or the thread through the rope, or thread through the thread, or rope through the rope? You're talking about touch. And again, an object is not that which you can touch. An object is not that which you can see. So don't bring the word see, touch in any way, shape, or form.
Well, I think it's just sad when I see these kind of things, because it's like, there's obviously a question that they want to ask, but, you know, when they ask it like that, it's like clash is touch. So it'd be nice to know what the distinction in their mind is between clash and touch, because there's obviously something. I mean, everyone understands clash is touch.
Okay, two more questions or comments. One person says, square is shape, but it is not an object. This is a fact. Well, we'll find out if it's a fact once you define the word object. And you have to defend the word object. You can't say, well, square is a shape, but it's not an object. Well, if it's not an object, define object, well, no. You got to define the word, and you have to defend it. You can't just put whatever gobbledygook comes to your mind. You got to define and defend. Define and defend, and then we're okay.
I like definitions. It makes everything kind of crisp.
And a lot of these people lose their religion. Losing my religion. They lose their religion with the definition of the word object. What does Bill Gates say? The definition of the word object destroys all religion. And that's why people are so uncomfortable with my definition. They try to fight it, and they say, well, everybody else believes in some other definition. We don't care how many people raise their hands. You got to defend your definition. You can't defend it, you don't have a definition. And the last one here is along the same line. Objects are 3 dimensions which we can see and touch. And so we have a human here on Earth, and we have the Klingon there in Klingon land on the other side of the universe. There's a gazillion miles between us. He's got a table. Is his table, which you cannot see or touch, an object? I want to know if it's an object.
It's right there.
Well, yeah, but I can't see the table the Chinese man has on the other side of the earth. I cannot see the table you are thinking of. So is the word table an object?
Well, the blind man can't see any of the tables.
So it's not. So he doesn't see any. So there are no objects for a blind man. He can't see or touch them. So now you got to define the word object first before you criticize. You can't just go in there and say, "Well, I don't like your definition." It's only because it destroys your religion.
Well, no,
That's the only thing.
I think there's a big confusion between that which you can see and that which is seeable. You know, like
I can't.
but
I cannot see a table that you're imagining.
Yeah, but then that's not an object.
It's not an. Is the word table? Does the word table represent an object? That's what I want.
Depends. Can I see it? Yeah.
It's when I see it. It's
what they're doing there is they're blending both your definition of object and exist.
Well, that's another issue. That's another issue. They make a synonym, but the issue is you have to define the word object. And I know it destroys your religion, the one you had all these years. I don't care about that. You
only have to define it if
you got to
use it in an explanation.
Yeah. All right, and we need a definition for the word object in physics because you cannot do physics without an object. So I'm sorry if my religion, my definition destroys your religion. Go ahead. Let's go with the questions.
With the questions.
Okay, go slowly here. Some people get angry if you miss them. If we miss you, I look at these anyways later on, and I'll address it next time. So don't worry about it.
You go into these, and that's where you get the next list.
Go ahead.
Buffering. All okay. Buffering. The question we answered earlier, hopefully, of the silver halide.
Okay. Yeah, silver halide. I didn't maybe complete that. I'll probably complete that answer next time.
Seemed like you went good into it.
Well, there were a couple details that I missed there that I did not cover, but I'll continue with the silver halide next time. But in general terms, it's more or less the notion of Compton effect and photoelectric effect. They're all the same thing because what they're saying compared to quantum says light comes in, hits the halide there and knocks an electron out. All these electrons bunch up in a crack or whatever, and because they have all this negativity, it attracts ions, and by doing so, you have the seed that builds up and creates this film. But that's the quantum version. Our version is, again, there is no hitting. There is no striking. There is no little particle that comes in and bangs against another particle. What you have is torsion. And the torsion moves the atoms, which are all merged, really molecules, because you're building molecules in a film. But think of them as atoms, no problem, just to get the notion. What you have is all these merged atoms, these electron shells. They spin, and what you have in another direction is, a low frequency light. And that's essentially the mechanism, the difference between quantum and the rope.
Hi, Bill. I don't follow the causal chain of your theory of man's extinction. How does decreasing genetic diversity and population lead man through his own policies to destroy his economy?
Just in a nutshell, what we're having is when you have less population, okay, let's get this straight. Less population means less demand. All companies, they expect more demand next year. They expect more and more sales. Growth. And growth ultimately is population. More population, no problem. There's more demand next year. Next year, more population.
People that need things.
Yeah, and what happens when population starts declining?
Population growth.
Yeah, or
population
starts slowing down first.
Population declining sounds like they're dying off.
No, it is, because that's what's happening. At some point, the old people have to die. And then what you have is more people die because they've all reached these old ages. We haven't produced new young people to fill in the vacuum. And that's when you approach zero population growth, known as ZPG. And when you approach ZPG, it means you approach population-wise, demographically-wise, right? When you approach the asymptote, okay, you're growing asymptotically, well, then demand starts slowing down. And the companies now, next year, don't have as much pull from demand. Remember, our human economy is an inverted population pyramid scheme, okay? You have it like that. And we expect more and more growth eventually. But what happens when that turns into, what we're seeing across the planet? And that's this, slowly the population pyramid is inverting. When that happens, you have less demand. And when you have less demand, a lot of companies close down, they merge, They sell less. You get rid of the competition. You get into monopolies, and what happens? You have to kick people out of their jobs, especially if you introduce, in conjunction with that, you introduce efficiency, meaning robots or whatever. If you make things more efficient, that only kicks more people out. You have, and so what happens? People will work for less. Will work for food, and at some point you work and you don't even get food. And so at that point, we have a problem with the inversion of the ecological pyramid, because at some point, people have no purpose to go to work because they don't make enough money to make it the end of the month, to pay their rent, to pay their food. So the guy, said, well, why am I going to work? Instead, I think I'll go outside with a crowbar and start breaking windows. And I think that's what's going to be happening in the next few years.
Is psychiatry or economics science?
Yeah, psychiatry, and what's the other one?
Economics.
Economics. There's science if you're going to explain. If you explain something, you're doing science. If you're doing descriptions, mathematics, you're not doing science. Description is not science. Mathematics was not built for science. Mathematics just describes. You measure, you get an equation, and you describe. And what have we learned?
Well, I guess it depends. You could break either of these down into religion or science, because we're talking about economics. You could be talking about explaining why the Depression happened. Okay. That would be science.
Okay.
But giving a recommendation on what to do with your money is also economics.
But recommendation is not science. Recommendation is religion.
That's what I'm saying. Either of these, psychiatry could be explaining why the person killed someone.
I see what you're saying. Yeah.
Whereas psychiatry could also be, what I recommend you do is you work out and you eat right so that you can think right.
Yeah,
a recommendation is religion, whereas explaining something, because these could be branches of the past or the future. It could be economics, what happened, or economics, what you should do.
Yeah, and again, I want to distinguish between a recommendation, politics, all that, religion, belief. That's different than explaining something. Here we're talking about mechanisms. If you're explaining something in economics of why something happens, what caused something to happen, then you're doing history. Same thing. It's science. If you can explain why Napoleon went to Waterloo, you're doing science. If you just state that Napoleon did go to Waterloo, well, you're not doing science.
Well, I guess the one time where you break that rule is when you're talking about human extinction, because that hasn't happened yet.
I explained that in the past. We're not going to get into that one,
just saying.
I'll kill you later on.
I mean, there was a debate here, so I guess I'll just turn it into a question.
Okay.
Are words objects?
No, of course not. Words are not objects.
Well, it depends. Because, again, the debate goes into saying, well, the air that I'm moving...
No, let's put it in the right context. Let's put it in the right context. You go to the dictionary, and there's only two types of words. You have words that represent objects because they have shape, or they represent things that have shape. Table, chair, tree. Those are all, the word represents an object. The fact that we use certain letters, and in different languages we have different letters, no problem. The point is that that word represents an object. There are other words that represent concepts, and those are those that which do not have shape, primarily, but the definition of concept is a relation. Okay, it's a word that invokes two objects. So object has shape, and concept, two objects. That's essentially in a nutshell.
That question means you say light is torque of a rope. In that question, light be physics if light is math.
If light is?
I don't understand it.
No, light. Again, light is math.
Torque is math.
Yeah, no. Torque is a verb. Torque is what the light does. We need to find out first what is light. In this case, the rope. In the case of quantum, it's particles, waves, which are just a bunch of vectors. But particles for sure. But it turns out that even in that case, the particle is not a particle. They're not talking about corpuscles. Again, they're talking about equations, etc. But assuming, if we go to classical mechanics, we're talking about corpuscles, which is what Newton had in mind. And we're talking about, all these particles that are moving, and that's the object. Fine, we all understand that. A stream of particles, that's the object that mediates light. What is light? the rectilinear propagation of all those particles. In the case of rope, the rope is the object. This is the object. But if I just show you a rope and just make it stand still, we don't have light. All we have is a rope. In order to have light, you need to have it torque. So we have to distinguish torsion from rope. Rope is the object. Torsion is what it does.
So light is the verb that the
plus
rope
the object.
Well, yeah,
the object plus the torsion.
It's kind of weird trying to distinguish the object from its motion.
Yeah, but you got to put them together, and you can say that the math part, the mathematics part, is the 300,000 kilometers per second. There's something moving there. But what is moving? Well, it's a torsion of what? Of a physical object called a rope, or a rope-like thing. It's a DNA rope-like thing.
Will we ever see Bill in a T-shirt with funny picture?
Yeah, I was like that in Iceland.
I butchered someone's question. Arthur, why? We're talking about how does decreasing genetic diversity and population lead man through his own policies and destroy his economy?
Well, I already said that.
Yeah.
Okay.
But that was the question.
Okay. Yeah, essentially, there it's what you have is you need more demand next year. And right now, what we're not producing is future demand. Our population growth is slowing down. And just to give you a number, we had 2.3 in 1963. That was our global population growth rate. Today, we're down to 1. And by mid-century, it's scheduled to go to 0 or close to 0. Anywhere from mid-century to the end of the century. But those are projections from the mathematicians, the demographers. They just calculate. I mean, I don't even know how much population there's going to be in the year 2030.
There's a lot of variables.
I mean, we don't know if an asteroid hits the Earth and kills
the population. We're talking about asteroids.
And kills all the Chinese, for example. We lost 1 billion people. So how can we predict what's going to be the population in the year 2030? There's no way you can predict that. All they do is project trends, and they say, well, we think that by mid-century there's going to be so much. But they don't know that. If girls, I mean, I've been asking a lot of the girls that I see out there, informal, right? It's an informal poll. A lot of them don't want to have kids. They don't want to have kids in the cities. They say, no, I don't have time. I don't have money. I want my freedom, et cetera, et cetera, et cetera. And they don't have kids. And so, we're not going to have what we need to replace the population. 2.2 approximately has been calculated by the demographers. You need 2.2 kids per couple. Right now, we're having 1 right now, and I don't know what we're going to have in the future. Half a baby.
Half a baby. What the fuck? Any thoughts on the Great Reset?
Yeah, it's just what we're having is just a glitch. That's all it is. We're not making anything substantial. Okay, there's nothing really profound any more than there was when we had recessions or depression, the 1929 famous depression. These are resets. They were resets. Okay, and we have resets every now and then whenever we have a depression or recession. But does that change anything? Does that change our culture? Does it change our global economic structure? It doesn't. I mean, I want you to think about something I was thinking about today. You have North Korea, okay, communist country. You have Cuba, communist country. Why do they need to trade internationally? I mean, you would think that these countries, they should be self-sufficient. They don't need the U.S. Why are they worried, for example, Cuba? Why is Cuba worried for the last 70 years? Why is Cuba worried about having this commercial blockade from the U.S.? Why is it worried? So say, okay, you guys want to blockade, you want to put a wall around us? We don't care. We're self-sufficient. Why don't they say that? Well, because no country in the world, including communist countries, are not self-sufficient. They need to trade. And whatever hurts their trade, international trade, hurts them big time. In the case of North Korea, well, they go through the little channel there and talk to the Chinese. The Chinese are supporting the North Koreans. Without China, North Korea is nothing. It would collapse tomorrow. Okay.
Recommendation is not opinion.
It is. Recommendation is opinion. Religion. It's known as religion. Anytime you have opinion, recommendation, belief, you're doing religion. Nothing to do with science.
Your assumption is light is torque of a rope, therefore light is math. Is this physics? How? I think they're.
Well, the physics. Here's the physics part. The physics part is the object. Okay. In this case, the rope, or whatever. It's a rope-like entity. That's what we're proposing. That's a physical object. What it does, which is torsion, that's the verb. So you have, and that's so the physics part is the rope, and you could say the math part is the velocity of torsion.
Bill, I meant to ask,
Yeah.
how does the rope torquing light result in polarized, unpolarized, circularly polarized, etc. light? How does polarizing filter block torquing?
I've got that. Okay, that's. I've got it in one of my
Sounds like
papers.
a big one.
No, yeah, it's a little complex, and again, what it is a picture is worth 1,000 words. I'll address that question next time. Now that you talk about rope instead of wave, okay, I'll address that question next time. I'm going to show you a picture of how polarization is done. I think I have a good grasp on polarization. Okay, and essentially is that well, I'd have to explain again. It's a picture's worth 1,000 words. One picture, you look at it and you say, okay, I understand. So I'll show that next time. I'll take a rain check, please.
Wind is when the air moves. Light is when the rope torques. What is there not to understand? Okay, he's answering the other person. Light is something we can't see, but it's a rope or torque. Is light the rope or a torque of the rope?
Yeah.
All of the above.
All of the above.
You're cheating. Bro.
It's A, B, and C. All of the.
Well, I guess the effect of light is the torque of the rope when the bump hits the end of whatever our eye is.
Because it's imagine this is the atom. I'm going to put my fist here, and this is the rope, right, ending at the atom. It doesn't really end. Remember, one thread goes around, the other one goes through. But this is the issue.
The surface.
You just take a rope and twirl it against your hand, and you're going to feel something. There is a. Put your hand. Yeah. Do you feel something?
No.
Okay, so you're moving something at the surface of the atom, which is the electron shell. Okay, the electron membrane, whatever you want to call it.
That's where the effect
balloon,
of light comes out.
Yeah, and so it's like if you've got a rope tied to your balloon and you twist it, the rubber balloon, you twist it. Well, the rubber is going to feel something.
There's going to be some change at the surface of the
right,
rubber.
and that's the point here. The point is that there is that little friction, and that's the aggregate of that around the electron shell is what we call charge.
Did Cuba/Iran benefit from your Pentium leaks?
I think it's not Cuba. Iran probably a little bit. I think it was mainly the Russians. The Russians did get, and East Germans. They took advantage of that quite a bit. And I know that for a fact, essentially. Yeah, I'll just give you a little bit there. When I went to Cuba several times, and I was in Pinar del Rio, which is on the west side of the country, and that's where they have their chip plant. Well, it was a very basic chip plant. They had very old, for what I studied, had very old equipment. The second time I went to Cuba, they had given the information to the Soviets. In those days, there was no Russia, it was Soviet Union. And the Soviets gave machinery for free in exchange for the information to the Cubans. When I got there, I saw the machines with my own eyes. I touched them, okay? And they had implanters, and they had aligners. And you can look up what those things are. An implanter is a small accelerator, ion accelerator. And they had these machines worth maybe $2-3 million that were given for free to the Cubans in exchange for the information. You tell me if the Russians got something out of that. They had to get something to give $2-3 million away.
Is the sun a rope?
The sun is not a rope.
There's a sentence before that. What is light? I see the sun and I think light as its synonym. The sun is a rope?
Well, the sun is not a rope. An atom in the sun is tied to an atom in your eye. Okay, let's assume you could look straight at the sun. Okay, well, that atom that you can see there, if you're atom man, right, is connected to an atom in your eye. And of course, we get tons of these, gazillions of these ropes tied to gazillions of atoms that form your eye. And that's why we can see, because we're seeing it. Hopefully you're seeing through a medium. This notion that light is not mediated by an object, that's when you introduce black magic. Hopefully, whenever you see, you're seeing through a physical mechanism that you cannot see or touch.
Yeah, it gets hard.
It gets a little complicated.
I guess we're trying to talk about seeing light.
Yeah, you can't see light. How can I see the rope that's coming straight into my eye, which is what torques and gives me light, allows me to see?
Or I guess the other way of saying is there's no way to not see it, because that is all we see.
Yeah.
If you think about it, all we see is light.
Well, you see another atom down the road because it's in the right frequency that's torquing and reaching your eye. But we cannot see, for example, the air because it's outside the visible range. That's the only reason we can't see the air. Fortunately, if we could see the air, we'd be in trouble because that's all we would see.
Yeah.
No, that's all we would see all day long.
We'd all be blind. That's it.
Okay. Well, folks, we'll see you next time on Sunday.
If something wasn't answered.
Yeah, okay. I do have an answer, but it's a little more complex. I'll explain a little more about polarization.
You can go down the list.
Yeah, I'm going to copy that and answer the man. Okay, we'll see you then on Sunday.